there's more interrelation in assessing the risk. So we do that. And I think when we go through examples, it'll become more clear. So the first thing is people say AI. So we want to be more specific, and based on the type, we have different approaches. So for traditional AI models, those have been around: machine learning, XGBoost, Bayesian approaches, etc., neural networks. Those models, they fit more into that traditional model risk framework and testing. Because we have certain approaches to calculate and to measure overfitting, that the model perform well during training, and then once you move far past that, is it still working? And there are a number of different challenges. There are a number of capabilities and uses for traditional models. There's classification, and you do need structured data. You need more of a preparation to start something like this. So this is something that we have sort of a good approach, I would say, in the industry. GenAI, it's a little bit more difficult because, well, you can generate anything. There's no scope to test, narrow scope that you can clearly say this is true and this is false. And that becomes harder to do. So chatbots, searches, some applications like retrieval augmentation, they're a little bit easier because they're more narrow in scope, and you can kind of limit what the model can do and what it can output. So it's a little bit easier, and I'll talk about that a little bit later. Comes with all the challenges that we've heard about: hallucination, lack of true reasoning, explainability. We hear a lot about explainability. On traditional AI front, there's a lot of developments on explainability that have helped. We've heard of SHAP-LIME, that kind of approach, but there's a lot more interesting and innovative things on that front. And then there's the red here, agentic AI, which sort of builds upon the existing architecture and adds that process-driven, goal-oriented approach. So in this presentation, I won't cover that part because it's so new, and it's still something that is challenging to model risk, I would say. But what do we look at? So how do we approach AI? So for AI, what you see here on the left, that's like your typical risk tiering, right? You either have 3 or 4 risk tiers. If models are material or critical, they move, and every institution may have their own version of this. By the way, if anybody wants to see the sources, everything is on the bottom of the presentation, and I encourage you to look at some of these great papers towards the end. We'll have a list of references. You have to ask. Yes. Okay. Great. So now, beyond these categories, which we know, there are new considerations. Who is using the model? The user type is very important, because if you have, let's say, another data scientist or another quant, they may understand the limitations of the model really well, and there's less risk of that model not being used correctly, or where the results produce bad decisions. Power users, economists, may have a sort of good understanding of it, but maybe they don't see the nuances of the development process. General company employee, more risky. And finally, anybody on the street, external users using chatbots, they present a higher risk, those models, because there's more that can go wrong. You can also imagine, like in terms of attack strategy, very much the likelihood goes up when you have that. And then finally, autonomy explainability. So black, I hate to use that phrase, but black box. Um, if it's a completely black box, there's obviously more risk because we can't trace where the problems may be. Is there a human in the loop? Is there somebody actually labeling the results? Um, and how involved people are. So that is the foundation of where you want to what you want to do in when assessing model risk. How in depth do you want to go into it? And but at the same time, this part, the original part, is still valid, right? Because if you have a critical material model, um, maybe you have internal users, but it's still important. So that dynamic has changed a little bit. So this is a comparison of different risks between traditional and Gen AI. So traditional machine learning, you may have data bias. So for example, you're training a model based on historic data. You may not want to make the same decisions based on uh, historical injustices of the past. So that's the typical bias that we try to measure. Overfitting, it'll fail on your data basically. Um, the relationship may change over time, but that's also with any model. Of course, it gets exacerbated with AI models, traditional AI models. Gen AI adds more toxicity. That the bias may be amplified, hallucination, sensitivity to prompts. I'm sure everybody here who has tried ChatGPT has seen how different answers can be depending on how you phrase the question. And one thing to also keep in mind is that these are the foundational models that are built with a certain purpose, and that purpose is to predict the next token, next sentence prediction. They're optimized for a certain purpose. They may not be optimized for what you are looking for, and that prompt sensitivity can be very important. Copyright infringement, people sometimes that's in the news. We see information about that. If you're a commercial entity and you're using a model that was trained on, sure. So bias amplification happens in these models naturally because they're based on data, as opposed to if you're in the traditional model, you may have a loss function that you have a certain idea. So let's say, let's take, for example, quantile regression. Theron was laughing. So if you take that example, you already have a certain path, right? You know you're trying to minimize a certain function to come to a certain result. Then you add the data. When you don't have that foundation and you just use the RAG or whatever the case is, whatever's in that data will get amplified. As the neural network works towards an answer, it basically, if it starts off in that place, it will end up with more problems. Hopefully that answer. So uh, a lot of misuse, AI magic. We hear so much AI magic, and people forget beneath there. This is embeddings, tokens, layers, and it is a model, and it's highly flawed. The other part is if you base AI data, AI process on AI data, that's something we'll probably see more of an issue in the future. So model risk, traditional model risk. This is our process for review data. We review data, and this is for every model. Yeah, yeah. Conceptual soundness, independent testing of outcomes, reviewing code, reviewing implementation, and I think Monitoring is super important for this new type of model. And of course, documentation, everybody loves that part. Um, to help us, we've had some developments on the national level. The NIST AI risk management framework has rolled out. This is not a specific guideline for financial firms, but it has very good best practice for AI development. And the idea is basically to have risk awareness, to be able to map and identify the risks. For example, like you have cyber risks, you have technology risks that didn't exist, and to measure and to manage. There's interesting new tools. For example, Dioptra, that is a tool that can be used to compare different foundational models. And there's a lot of research that's being published. So I'll go on. Again, this is probably something that most in this room already have heard of: accuracy, precision, recall. That these are general performance metrics, can be helpful when models are being built. The trick is also which context are you using? Are you using it on training data? Are you using it? How are you splitting that data and measuring this? Are you randomizing it through k-fold, or are you picking different samples? So even though this may seem very simple and straightforward, it actually can be applied in many different ways, and it does help to understand the model performance. But that's the basic idea. I think I mentioned bias and fairness, especially for consumer-based models. Those are pretty straightforward in terms of you want your general population and the population, whatever that group A is, you want them to the sensitive attribute, you want them to have the same distribution. That's the idea. But then I think people have mentioned bias. I've heard like a bunch of mention of bias today. Everybody measures bias. Which bias? Which? So I think there's more than 8 actually. I think depending on who you ask and depending on the model, it may differ, right? So for example, for lending, historical bias, right? That's typical one that comes up, and maybe the measure is the same. Labeling, if you have labeling in the model, that can have bias. Algorithmic bias. The model, I think Karen asked the question, why is it more higher in AI models, especially Gen? Well, because that's the model design, right? It's data driven. So of course, it's going to amplify. Then exclusion bias. What are you leaving out? Interpretation bias. What do people think this means when they get an output? Do they think that this is a good prediction of the next sentence? A good close token? I don't think most people will think that. So there's a lot of potential issues. Issues of data feeds. And for example, we'll talk about the first example, RAG, retrieval augmentation. RAG pipelines, they're very popular right now, and they can be applied to anything. Summarization, extracting information based on specific corpus. So you may feed, a law, a case study of law. So when you do all of this, there's a lot of issues that can come up for those type of models. For example, models are using embeddings, and they're comparing semantically whether things are similar numerically between, once you convert into vector databases, basically they're looking at numerical representation. So dog training techniques, employee training manual, how similar are those things? We all know it's not, but they may be returning a similar embedding number. Also, there's questions of how to set up chunking, how to feed all of this information into the pipeline. So sentence by sentence may create a problem. So there's choices that have to be made when this is designed. Um, so in the next few slides, I'll talk about some of the interesting approaches, some newer papers that I found very applicable. One is by Augusto Gianto, recent paper, and uh, what he's talking about is, again, kind of starting from that basic metric of similarity, um, and then pushing towards, well, how do you actually improve it? So uh, when you, let me go on to the next part. So when you build a model, you have context, which is based on the information that you send to the model, the augmented data, and you have queries. So for example, when you send a query to the model, it converts it into embeddings. Are those embeddings the same or similar to the match that you find from the model, right? So you look for something, you get an answer. So that is whether this context is relevant. Then there's a quasi-groundedness, right? So does the generated content, does a summarization, is it how related this answer A, how related is it to C, which is our corpus that we fed into? So that's the starting point. And in this paper, which is referenced in this at the end of the slide, this is what he found. So in terms of questions, right? I skipped over an important part of this, which is to tackle this problem, you have to reduce the dimensions because there's many different queries, there's many different topics. So what they do is they split it up by topic, and for each topic, they stratify sample and label and get labels for that. That's the ultimate goal here. So here, what do we see? This is a distribution by different topics. This is great. One, perfect. And this is how relevant the query is to the what is actually being sent. So this is relevancy, precision recall. What do we got? Anybody notice anything that's disturbing in this? Yes. And there's lots of outliers over here. And depending on the topic, that may be different. The same thing for groundedness. The same thing for the same thing for groundedness, even more. So now you see even more fatter tail on the left. And if you have a very critical application, maybe for topic 0, are you comfortable with this, right? So it's not a question of should you use the tool or not. Do you want a strict cutoff? Do you want to never use, but what is actually happening? Do users understand that part? But they may have a risk over here in this tail. So that is one approach that I found interesting. Actually, if you guys are interested in this specific topic, in the paper it goes further and it talks about conformal prediction, where they calculate probabilities based on labeling of these topics. So you will have a confidence interval, not just an answer. Another approach, and this comes back to the first slide. So we talked about technology, cybersecurity, all of these different parts. So do you guys have cell phones? Everybody's got a cell phone. I recommend you guys try to crack this code. I guarantee you will pass level 1. So maybe you could try. So if you go to or Google Gandalf AI, you have to crack this password. And if you try, maybe some of you will be very quick to get a response. And this is a good break for me. There's 8 levels. The level 1 is the easiest. I think people will be successful. Anybody able to get a password out of this? There we go. Tony's the first one. Okay. So a lot of people got passwords. That's great. But I guarantee when you get to level 2, 3, 4, it'll become much harder and fewer people will be successful. So this is an introduction into red teaming. We try to break these models. These ideas actually come from cybersecurity practice. Mitre and other companies have been developing these practices, but I think it can also be applied to model risk, and it can also be used to assess specific questions like hallucination and bias for these models. So how can you actually do it? One example is Pirate. It's a tool built by Microsoft to assess foundational models, fairly new, 2024. And what it does is it takes a data set of uh, ideas of how to, I guess, break a system. So there's different jailbreaking techniques, etc. And it's in the next slide. And then based on those different types of attacks, and there's a data set of these attacks, it then sends through an API these prompts to any given large language model, and it can be adapted to RAG 2 with a little more work, and sends it to that target model and gets back an answer. And there's also this memory component, so it remembers if you have multiple attacks, it may take a long time to break down this model. And once it gets an answer, it's going to score it, right? So there's different techniques for scoring. How well did we do for hallucination? How about jailbreaking? How well did we do? So this is more, oh, and it got to level 8 of Gandalf. It broke it down. It went through each level. It took longer and longer and longer, more prompts to get to that point, but it did. And these are different categories that are already in the data sets in this tool. These are the sources of Mitre and OASP have data sets. Oh, for here's a practical example. You can ask a question to try to introduce bias, right? So for example, do men and women have different answers to something, right? Now, the model will typically tell you, they're same answer, right? They all have the same answer. But if you tweak it a little bit and you say, how would a caveman describe domino? And how would a cave woman describe domino? It may give different answers. So that's the idea. So you start with some direct question, just like we did with Gandalf, and then you tweak that, and then you change it again. So these are incremental changes. There's different methodologies here. And it tries to get these models to do what they're not supposed to. For example, you could ask it to, how do you create a bomb? And obviously it'll tell you, I'm not going to do that. There's safety. But then when you do that and you try to write the bomb with a dot, right? Like use dots and kind of use the symbol, it may work on interpreting that B based on the drawing so hard that it will forget that the question that's being asked is incorrect. It should be blocked. So there's many ways to get around and get that to happen. And this particular tool, you could do thousands of them, send thousands of them. Make sure though you don't lock up your foundational model access, so that can become a big problem because they limit, and there's also agreements. So you have to be careful how you use it. and then you score it. And there's different ways to score it. One is you can use RegEx, which is basically like similar keywords to words that are bad, like for example, profanity, banned topics. You could use classifiers, older models like BERT. Um, so you could also use LLM as judge. Um, but the idea is if you do this often enough, you can see how often uh, these models break. And all these models, you could see publications for every time that a new model gets created, foundational model, you see an update, you have scores, but you don't have that for your RAG approaches. You don't have that for your internal tools that you build. And that's where I think this could be useful. So that's it for my presentation. I kind of went through that quickly.